There are some students that are still struggling with basically everything in this class. Obviously, that's not my ideal. So what I'm going to do is I'm going to go ahead and work the entire warm-up with you. For those who are still struggling on this is domain and range, function one-to-one. What am I looking for here? In order to determine if this is a function, you have to check your x values. So remember points are x comma y. So this is an x, this is an x, this is an x, and this is an x. Got it? They're all unique numbers? Yes. If they're unique numbers, meaning they don't repeat themselves, it's a function. Now let's do one-to-one. We're going to check if it's a function, you check for one-to-one. Are the y's all unique? Let's check it out. Yes. 3, 4, 5, -5, those are unique numbers. So yes, this is one-to-one. Domain. These are associated with the x values. Remember with domain at the front of the room, you have to use either, depending on what the situation is, parentheses, brackets, or I don't know what these are called. I should probably learn what these are called. These suckers right here. These right here. We use the bottom ones that I just drew for set notation with single numbers. What do I mean by that? Well, this has, let me scroll down and show you. This is a graph and a picture. It is not a single number. It's continuous stuff. So we use different things. This right here, this notation, these are individual numbers. So this is the one we're going to use. So what does it look like? You draw this, and then you just list your numbers. Typically, I want them in order from like smallest to largest, but I haven't been grading on that. So I'm not going to do that now. I'll let that be your next year's teacher's problem. But typically, we organize these from least to greatest, but it's not that big of a deal. Now let's do the y values. The y values, check it out. We're just going to list them. 3, comma, 4, comma, 5, comma, -5. And then you are done. This, use the back of the room, y'all. Next to the math be kind sign, next to the math be kind in the back of the room where it says math, and then it says be kind on my wall. These definitions have been on the wall. I'm not kidding. I think since August. So right there, we're using these words from now on. So make sure you have these. This one right here, number 3. This is also one of those function one-to-one things. Check it out. It's kind of hard to read on this thing right here. Anywho, if you really want to know a spoiler, they're the same points as number 1. So number 1 and 3 have the exact same points. So the answer is going to be the exact same thing. You'll notice I see some kids doing this, like trying to connect the points and make their own picture. No, we don't want that. That's not what we're doing. If the picture's not there, don't draw it. So function one-to-one, we know that it is because it's the same numbers as up here, the same points. And if you want to really know the answer, it's the same domain up there, same range down here, etc. If you don't believe me, list out the points. All right, distribution. I'm going to go ahead and work this one. You need to know what this is. Remember, it's multiplication into parentheses. That's what distribution is. So I need you to make sure that you can explain that to me. We're going to multiply in, going to multiply in. 4 times 2x is 8x. 4 times -2 is -8. That's an example of distribution. All right, now I'm going to go ahead and talk about grouping. Grouping is essentially putting common terms together, combining like terms. So what do I mean by that? Check it out. 8x plus 4 minus 2x squared plus 10x plus 8. Let's see, minus 4x squared. We're going to go through and label the families together. I'm going to get my blue out. Check it out. X is a family. X is a family. Those are the only families in that are the only x's there. X squared is a family. X squared is a family. Now we're going to go over here, and constants are a family. We have 3 families there. We're going to combine like terms. How do we do it? We add the coefficients together. What are the coefficients? Well, if you do number 2, you should tell me what coefficients are. They're the numbers in front of the variable. So let's start with our x squared. We're going to start with our highest exponent first. -2 minus 4 gives me -6x squared. So that's boom, boom, taken care of. 8 plus 10 is 18x. This is grouping, y'all. And then 4 plus 8 is 12. Okay, Now, inverse. This is basically a mathematical opposite. That's basically what it is. Opuesto. Opposite, opposite. So how do I represent that? Well, what's the opposite or the inverse of addition? Subtraction. What's the opposite of multiplication? How do we find the opposite of that? That's an ugly little star. That's so sad. That's supposed to be multiplication. The inverse is division. What if I had a squared? What if I squared it? The inverse would be square root. That's that. Independent variable. We haven't gone too much into this. For the purpose of this class, the independent variable is always going to be the x-axis, and the dependent variable is always going to be the y-axis. I'll describe this more for the rest over the next couple months, but it's just one of those concepts that like either clicks or it doesn't, and it takes a while for it to click. But just know that the independent variable is the x, the dependent variable is the y. All right. So I edited this assignment right here, number 5. On your version, you can see what I did. I'm going to go ahead and add it here. I added a hole here. Boom. I added a filled in hole, like a non-hole here. And then I added a hole here. Boom. And then I had it filled in here. So how do I solve this problem here? It's pretty simple. Remember that domain. Oh, is it a function? Use your vertical line test, up and down, 1, 1, 1. Yes, it's a function. How do I know if it's 1 to 1? You're going to do a horizontal line test. Boom, boom, boom. If it crosses more than one time anywhere on the graph, it is not a 1 to 1. Domain. We're following the x values. This is a -2. It's kind of hard to tell, but you'll be able to see it on your paper. This is a -2 right there. There is a filled in hole there. The filled in, it's not a hole, I mean. So since it's filled in, we know that it's going to be a bracket. So it starts at -2, and then it goes all the way up. It ends on a hole at number 2, and the hole means parentheses. Now, I want to check out this bottom one here. The reason why this bottom one matters is because y'all need to understand this. Do you see how there is a hole and a non-hole at -2 for the range? Guess what? The tie goes to this. The tie goes to that person. So since the tie goes to him, we're going to put a bracket there. And it starts at -2. And then check it out again. It goes all the way up to where y is equal to 0. And do you see there's another tie? The tie goes to this fella. So it ends up looking like this. Part of the nuance, I'm going to be doing problems like this to make sure you can actually fill in the domain and range correctly. I filled in the arrows on number 6. The arrows on number 6 I filled in. So it looks like this on your paper. Remember how this works. I'm going to do blue as domain. Is it a function? 1, 1, 1. Yes, it is. Horizontal line test. No, it's not. If you're still struggling with that, how I'm doing that, I don't know what to tell you. Get help from your neighbor. Domain. Right here, domain, remember about our arrows. Our arrows are always, not always, but 99% of the time going in 2 directions. So in this case, I know I'm going this way with this arrow, and I know the arrow over here is going this way. I'm going to split it up into 2 arrows, 2 directions, y'all. This is going up. Check it out. This is going up. So now I can read my domain and range much easier. So let's go back to domain. My x values don't have a start. If we try to go from the very left-hand side, the negative side, you can see that it's going into negative infinity forever. So going from left to right, where do we end up starting? Negative infinity. And remember, parentheses always belong with infinities. Like infinities will always get those. So we're going to walk, we're walking, there's x values, there are x values. What ends up happening? My x values keep on going forever into positive infinity. Now we're going to switch to green and do the range. Remember, the range is negative to positive, and in this case, it's the y, so it's going to be from bottom to top. What's my first bottom number I see? It's -2, and there's no holes there, so it's going to be -2. And then I'm going to follow it all the way up. You see how my arrows are going up forever into positive infinity? That means it never stops, and that's my domain and range there. All right, we're going to move on to the next stuff. This right here. I still see kids a little bit struggling with this, but I'm pretty impressed with the work so far. I'm going to color code. This one is going to be blue, and this one is going to be red. Now, go ahead and take a look over here at problem 8. It wants the equation, both slopes in the equation. What do I mean by that? Remember, And don't write this down. If I had 8 divided by -2, that is -4. But if I had -8 divided by 2, that is also -4. But here's the deal. They're the same number, but they contain different instructions. It's different numbers. I mean, same number, different instructions. So that really matters. And I want you to make sure you write both of your slopes. So on 7a, what do we have? Remember, if there's one negative, it can either go on the top, the numerator, or it can go in the bottom, the denominator. Boom. That's that. So now I'm going to go ahead and fill in my slope for the next one. There's also a negative on that one. So remember this. Boom and boom. Same number, different directions, different instructions. Okay, let's go ahead and graph these suckers. -4, this is my y-intercept. So starting here, this is my y-axis, y'all. Starting here, I'm going to go down -4. 1, 2, 3, 4. Boom. I've now started. Remember, the numerator is up or down. When it's negative, that means go down 2. So I'm going to use the first slope. It says go down 2, 1, 2. And then we have a +3 down here. The bottom number, the denominator, is left to right movement. Positive means go to the right. So we go -1, -2, and then 1, 2, 3. Cool. Now I want to go to the other way for my point. So I'm going to do that. I'm going to use slope 2. I'm going to go back to my y-intercept, and I'm going to use it. The numerator, up-down motion. Positive means goes up. 1, 2. The -3 means go left 3. 1, 2, 3. Let's do it again. 1, 2, 1, 2, oops, 1, 2, 1, 2, 3. Boom, look at us go. Now I'm going to not draw my lines yet because y'all know my work is sloppy. So I'm going to go ahead and do B, equation B. -3, that's the y-intercept. 1, 2, 3. That's where we're starting. I'm going to use the first slope. It says go down 1 and then right 2, 1, 2. Go down 1, 1, 2. Okay, we're not intersecting over here, so I'm going to use the other slope. I'm going to go up 1, 1, 2. No intersection yet. 1, 1, 2. 1, 1, 2. There it is. 1, 1, 2. Boom. We found our intersection point. Where do we intersect at? Let's count it. -1, -2, -3, -4, -5, -6. We went to -6, comma. You see how we didn't go anywhere up and down on the y? It's going to be 0. So you can see I can attempt to draw the line on here, but y'all, you know how it goes. Let's see how I do. Oh, Lord, child. Oh, Lord. Look at that. You do not want Mr. Warren painting lines in your house. Right here. Let's see if we got this one. Let's see if I can do this. Oh, wow. Wow. Uh-huh. That's supposed to be a line. See why I didn't want to draw it? It's supposed to cross right here. I did a little bit better on the live answer key than I did here. Um, show me up. Do better than your teacher, because that looks like garbage. All right. Let's go ahead and go to number 9. Check this out. I am showing you a trick on how to clear fractions. When you see fractions in an equation, the first thing you're going to do is ask yourself, do they have the same denominator? And you're going to look. And if they do, you're going to go ahead and pull out this clearing fractions trick. You're going to multiply by the denominator, and you're always going to multiply by a positive number. So you're going to multiply by +3 right there. So here it goes. When we multiply, you can go 3 times -2 over 3. What happens? This cancels out, and you're left with -2x. You're left with -2x. I'm going to multiply again. So you go into here. 3 times 3 is 9x. Let's do it again. 3 times -4 is -12. Let's do it again. And again, this is just a trick, y'all. I've modeled this a few times now. 3 times 5x is 15x. Let's do it again. Remember the trick. This cancels out. So we're left with just a -5 right there. -5. And then let's multiply again. And we end up with -5. Oh, sorry, -15. All right. Now get your equal signs lined up. Get your equal signs lined up. And what are we going to do? We have to combine like terms. So look at the left side first. Rules of normal mathematics. No opposites yet. -2 plus 9 is 7x. Then we're going to bring down the -12. Boom, boom. Now we're going to look at the right-hand side. The right-hand side is 15x minus 5 minus 15. The constants, that's the numbers by themselves, they are family. So I'm going to bring down 15x, and then this is minus 5 minus 15. That gives me minus 20. My twos, y'all, they are just sad. All right, now what I'm going to do is I'm going to subtract the 15x on both sides because I need to group, but this time I'm going across the equation sign. And remember, whenever you cross the equation sign, you have to do an opposite of some sort. Since we're combining like terms, we're going to do an opposite there. 7 minus 15 is negative 8x. I'm going to bring down my negative 12. This is canceled out. Boom, boom, and I'm going to bring down my negative 20. Now I'm going to add my 12 on both sides. At this point, most of us should be cool with this. If you don't know why I'm doing this at this point, the opposite of a negative is a positive, so I must do the opposite, and then I must do it on both sides. This cancels out. Negative 8x equals negative 20 plus 12 is negative 8. And then this says negative 8 times x. The opposite of that is division. So we're going to divide this whole thing out, and we end up with x equals negative 8 divided by negative 8 is a positive 1. So the whole thing on number 9 solves to a positive 1. Got it? So I'm going to erase my work. So push pause if you need that again. I'm going to erase my work so I can go ahead and do number 10. Number 10. This is something we've been doing for a while as well, too. I hope y'all understand what this is at least telling you to do. I have a lot of kids that pretend to be a lot more useless than y'all are. I'm kind of getting tired of that. So I'm ready for y'all to learn this because every single child in this school can learn this concept. It is not hard. So we're going to go ahead and do it like we're brand new at this. This says evaluate at f of 2. What does that mean? It means there's an equation named f. There it is, f. And what we want you to do is we want you to, instead of having an x, we want you to plug into everywhere you see an x. Everywhere you see an x, we want you to plug into. This is basically a y with instructions. It looks funny, but it tells us what to do. So now we're going to plug in our 2. I'm going to leave open my parentheses. You'll see what I'm doing in a second. Squared. Let me get this. Minus 2. A lot of math, y'all. Going to put in my parentheses there. All right. Squared. So what do we have for our 2? Our x. We have our 2 right there. We have our 2 right there. And we have our 2 right there. Everywhere there's an x, we're going to replace with the 2. Got it? Now what we have to do is PEMDAS. Now we need PEMDAS. This is still something that y'all are not paying attention to. I don't understand why. I have been talking about this for a while now, and I really would love y'all to pay attention to it. Parentheses first. What you do is you cover up the 2 parentheses, and you only look inside. So inside, I see 2 times 2 minus 4. On this parentheses, I see 5 times 2 minus 8. Is there math we can do inside the parentheses? Yes. That means we do those first. So watch what it looks like. I'm going to bring down my negative 3. 2 times 2 gives me 4. Minus 4 gives me 0. So this whole little thing inside here comes down to 0. And then I'm going to bring my squared here. Show your work. I'm going to bring my 2 down here. Now, what's going on inside here? 5 times 2 is 10. Minus 8. See how I'm doing this? That gives me 2. So this entire parentheses evaluates to 2. And then I'm going to bring down my squared. Write the equal sign. 0 squared. Oh, now we have to go to parentheses are over. Now let's look at exponents. Do we have exponents? Yes, we do. We have 0 squared, which funny enough is just 0. So some of you know you can just get rid of this immediately, but show me your steps anyways, because I'd like to see the steps. An exponent here, 2 squared is 4. So this becomes 4. No more exponents. Do we have multiplication? Yes, we do. Negative 3 times 0 is 0. And then negative 2 times 4 is negative 8. So what do we end up getting? 0 minus 8 is negative 8. So the answer comes out like this. The answer comes out like this. Remember, this f of 2 is just a y, but with instructions. So this answer says this. When x is equal to 2, y is equal to negative 8. When x is equal to 2, our y is equal to negative 8. And ta-da, you've solved it. Number 11. This is the one I'm going to have y'all start on today. This is the bare minimum. Most of y'all can do this, but I need y'all to get faster at it. I want y'all to get better at this. So here we go. We're going to look at the left-hand side first. Can I do normal math? The answer is yes. So I'm going to distribute. I have 6x minus 6, and I'm going to bring down my plus 2x. All right. I'm going to go on my right-hand side. Can I do some normal math? Yep. I'm going to distribute. Negative 4 times 5 is negative 20x. Negative 4 times negative 4 is positive 16. And then I'm going to bring down that plus 6x. All right. Now I'm going to check my left-hand side. Can I do normal math? Yep, I can combine like terms. My x's go together. 6 plus 2, I'm adding the coefficients, is 8x. Boom, boom. And then I'm going to bring down the minus 6. Now I'm going to look on the right-hand side. Can I put anything together? Yes, I can. I have x's again. So negative 20 plus 6x is negative 14x. And then I'm going to bring down my 16. All right. Get your equal signs lined up. Get your equal signs lined up. I'm going to get my x's on the right-hand side. We're going to group across. We're going to group across the equal sign. That still is addition and subtraction. So what's the opposite here? Remember, if we cross the equal sign, we have to do some sort of opposite. One opposite. This cancels out. Make sure you line up your work. I want to see that you're putting your x's together, your variables. 8 plus 14 is 22x. I'm going to bring down my twos are so sad. I'm going to bring down my 6, and then what's left over on this side? My 16. I'm going to add the 6 on both sides because I want my numbers, my constants on the right, and I want my variables on the left. This disappears, and I end up with 16 plus 6 is 22, and then I end up with 22x. So 22x equals 22. How do I solve it? Well, it says 22 times. 22 times. The opposite of times is division. So we're going to divide on both sides. We're going to divide on both sides. This goes away. We end up with 1x because 22 divided by 22 is 1. That's a sad x. Let me get rid of that. 1x. And then 22 divided by 22 is 1. And remember, we're math people. We don't want to see 1x. So you're going to write your answer as x equals 1. And that's your total thing right there. Good luck with the warm-up. Any kid who's still struggling on this, I'm going to sit you down and make you watch every single one of these problems. Good luck.